lesson we are going to be looking at making salts from metals, and for the learning objectives today we are going to look at reactions of magnesium metal, zinc and iron with acids, specifically hydrochloric acid and sulfuric acid. Then we're going to be looking at how we can get salt crystals from these reactions. Any acid metal reaction, we say that a reaction can only take place between an acid and a metal is if that metal is higher in the reactivity series than hydrogen. Now, looking back in your notes, you should remember that the metals can be arranged in a particular order. We have metals that are less reactive than hydrogen, being copper, silver, gold and platinum. Metals above hydrogen were lead, tin, iron, zinc, aluminium, magnesium, calcium, sodium and potassium. So when we look at the reactivity or the reaction between a metal and an acid, we have to refer back to our reactivity series to understand what's going on. So can you just note this down first? Reactions between metals and acids. Reactions between metals and acids can only occur when the metal is more reactive than the hydrogen. Now this is important. More reactive than the hydrogen in the acid. When we looked at the reactivity series and the order of reactivity, hydrogen and carbon were like marker points. And as I just mentioned, we have a set of metals that are below hydrogen in that reactivity series. Next point is that all acids contain hydrogen. Now, this is why we have to refer to hydrogen in our reactivity series. And the hydrogen, when we're dealing with acids, is released in an ion form when dissolved in water. So we say that all acids contain hydrogen, which is released in ion format. Let's say in an ion format, hydrogen ions, is released in ion format when dissolved in water. What this is saying is that we are dealing always, when we're looking at our acid and metal reactions, we are dealing with an aqueous solution. So we are dealing with an acid where the H plus ion is released into an aqueous solution when it's dissolved in water. So This is important because then the next point which leads on from this is that dilute acid is reacted with the metal. This is what we mean when we say that we have an aqueous solution. Regarding acid plus metal reactions is that when a reaction between an acid and a metal takes place, a salt is produced. So in any reaction between an acid and metal, will result in a salt being formed. So whenever you react an acid, be that hydrochloric acid or sulfuric acid, with a metal that is more reactive than hydrogen, you will get a salt being formed. Now, the salt is formed because the hydrogen in the acid is completely or partially replaced by the metal ion. So, what we say is that salts are formed because the hydrogen, now this is a hydrogen ion that has been released into an aqueous solution coming from the acid. So salts are formed because the hydrogen ion, or the hydrogen ions, are completely or partially replaced by metal ions. So salts are formed because the hydrogen ions are completely or partially replaced by metal ions. Sentence. Salts are formed because the hydrogen ions are completely or partially replaced by metal ions. Now, the question should arise, what happens to the hydrogen ions? Now, they are completely replaced, meaning that hydrogen is pushed out of the solution that is present there within the aqueous solution. So what I want you to do is pause the video here, and I want you to note or jot down what you think is happening to the hydrogen ions if they are completely or partially replaced by metal ions. What could happen? If you have an answer that's just jotted down with respects to the hydrogen, I'm going to give you a word equation, and I hope it will be clear, or the answer is clear, once I finish this word equation. Okay, so for any metal and acid reaction, we have this standard word equation. Metal plus acid gives us salt plus hydrogen. Now, from the periodic table, when we looked at the periodic table, if we have hydrogen, and we're at room temperature, what state is hydrogen? I want you to think about that as I move on to the next equation. Hopefully right now it's become quite apparent what hydrogen is being released as from the aqueous solution. Alright, I'm going to give you a word equation with a specific metal now. So let's say we have iron plus hydrochloric acid gives us iron 2 chloride plus hydrogen. So this is our word equation when we have a specific metal, for example, iron. I want you just to pause the video here again and tell me what would, or write down the equation for the reaction with silver and hydrochloric acid. So I just want you to just pause the video and see if you can write down the equation for a reaction with silver and hydrochloric acid. Okay, so if we were to look at silver and hydrochloric acid, you should have this, a big cross, or you should have stopped there. This is because silver is lower than hydrogen in the reactivity series, so you would not have a reaction taking place. A reaction would not go forward because silver is below hydrogen in the reactivity series. Okay, now going back, I'm going to give you a symbol equation for this word equation, and I want you to complete this symbol equation. So let's do it directly underneath. For iron, if we put the symbol for iron down, I'm going to give you the symbol for hydrochloric acid. The corresponding salt that is formed, and the hydrogen is represented there. I want you to pause the video here and I want you to complete this equation fully. So if it needs to be balanced, balance it. If you see anything else that needs to be added, add that also. So I want you to again pause the video here and complete this equation fully. Okay, let's see. Balancing this equation, you should have 2 here because we have 2 hydrogens on the right hand side, and we have to make sure we have 2 hydrogens on the left hand side. Iron is on its own, and it's 1 iron on the left hand side, 1 iron on the right hand side. Chlorine, we have 2 chlorines on the right hand side. By putting 2 here, we also have 2 chlorines on the left hand side. So this is now balanced. But the equation is still not complete, because in any equation, specifically when we're dealing with symbol equations and chemical reactions, we have to know the state symbols. Iron is a solid at room temperature. We're dealing with state symbols when the conditions are at room temperature, at standard conditions. Iron is solid. HCl, hydrochloric acid. Based on our definitions at the beginning of this lesson, we talked about how the hydrogen in all acids we are going to deal with are hydrogen ions that are released in water. That means if we have an acid dissolved in water, we have an aqueous solution, and that's represented by AQ. Now the salt, the corresponding salt that's formed, is also in an aqueous solution. Now this will change later on in the lesson when we extract the salt from the aqueous solution. That state symbol will eventually change. However, in our initial step, the salt is in an aqueous solution. Now the hydrogen, the H2. Hydrogen in standard conditions at room temperature is a gas. So you should have been comfortable in stating that iron was a solid. You should have been comfortable stating that hydrochloric acid, because it's dissolved in water, is aqueous. This I can understand if most of you got wrong in terms of the aqueous solution, in terms of the salt here. I can understand if that was a bit tricky. However, all of you should have been comfortable with stating that hydrogen is a gas. So just be aware that when you're dealing with a metal acid equation, you will have to be comfortable with balancing and state symbols. And remember that your acid is acid dissolved in water. That means it is in an aqueous solution. The corresponding salt, if no treatment is added, it also stays in an aqueous state, and you have hydrogen gas being given off. This reaction with iron and hydrochloric acid, our product is salt and hydrogen. What I want you to do is pause the video here, and I want you to tell me how you could prove that hydrogen gas has been given off. So let's say you're conducting this experiment in a test tube, and I want you to tell me how you could prove that hydrogen gas has been given off, and I want 2 points for this answer. So 2 ways in which you could prove that hydrogen gas has been given off. So pause the video here and just write a few sentences on your paper that proves that hydrogen gas has been given off. Let's say we're conducting this experiment in a test tube with a small amount of iron metal and some dilute hydrochloric acid, and I want you to prove that hydrogen gas is being given off. So what 2 statements can you write down that proves that hydrogen gas is being given off? The first proof that you would say is that this is by observation. So as you carry out the experiment, you should be observing the changes that are taking place. So an observational proof for hydrogen is that because it's a gas, bubbles are given off. Or you can say bubbles are given off or rise through your aqueous solution. And the rising of the bubbles is an observation that hydrogen gas is being given off. It's not conclusive proof that it's hydrogen. You can only infer that a gas is being given off. You confirm that that gas is hydrogen by conducting a test. and that test is the lighted splint test. So holding a lighted splint near the test tube opening results in a squeaky pop. So you hear a squeaky pop due to the hydrogen igniting, and because you bring the lighted splint near the test tube opening, near the top of the test tube, because bubbles are being given off, a gas is rising. This gas, because it's hydrogen, when it comes near a lighted splint, you get that characteristic squeaky pop. So you know that hydrogen gas has been given off. You can see the reactivity series, the metals in order of reactivity, and you can also see their corresponding groupings in terms of how readily they will react with acids. Notice that potassium and sodium and calcium will react violently with your dilute acids, and you can see that it is likely to explode. Magnesium through to lead. Now these are the metals that are generally used in experiments to show the reactions that occur with dilute acids, and these are the ones that we can safely do in the lab. And as you can see here, copper, silver and gold do not react with dilute acid. Now, what I want you to do is, could you put down on your piece of paper or in your notes the groupings of the metals that react violently with dilute acids? There have been exam questions which ask for reasonings as to why potassium and sodium are not reacted with dilute acids, and you have to be able to explain that these metals, because they are very reactive, these are the alkali metals, they're very reactive, and they react violently with dilute acids. So that's why generally they are not used in reactions with metal acid reactions. You should also be able to explain the test for hydrogen, and it's put in another way here. If a lit splint is held to the test tube, squeaky pop sound is heard, it shows that hydrogen has been evolved. Okay, and the lower the reactivity, the less likely it is for the reaction to happen. I want you to give me a word equation and a full balanced symbol equation for two reactions. The first reaction is zinc plus sulfuric acid and the second one is sodium plus hydrochloric acid. So for each one I would like a word equation and a full balanced equation, chemical equation. Use the hint at the top to help you. First question, where we have zinc plus sulfuric acid, you should have this word equation. Zinc plus sulfuric acid gives zinc sulfate plus hydrogen. So that's your word equation. Zinc plus sulfuric acid gives zinc sulfate plus hydrogen. Your chemical equation, or balanced chemical equation, symbol equation, should have been this: zinc solid plus H2SO4 sulfuric acid aqueous gives zinc sulfate, again aqueous, plus hydrogen gas, H2 gas. So the mark was 1 for getting the chemical symbols correct and making sure it was balanced, and in this case there were no additional steps. And the second mark would have been for making sure that the state symbols were correctly allocated. So this is an example for zinc metal with sulfuric acid. Now the other one was looking at sodium. So the word equation for this would have been sodium plus hydrochloric acid gives sodium chloride plus hydrogen. Now what's important here is that to note that sodium chloride is common table salt, so it's something that we consume. Symbol equation would have been Na plus HCl gives NaCl plus H2. Now notice that this is not balanced, so if we have to balance it, we have to make sure that the left hand side and the right hand side are balanced. If we take the hydrogen, for example, we can see there's 2 hydrogens there in the subscript for hydrogen on the right hand side, so we can put a 2 here. Now the hydrogens are balanced. If we go through and check with the chlorines, we can see we have a problem now. Left hand side is 2 chlorines, right hand side is 1 chlorine, so let's put a 2 there and see what happens. Now the hydrogens are fine, the chlorines are fine. The sodium seems to be a problem here, where you have 2 on the right hand side and 1 on the left hand side, so let's just put a 2 here. Now check it through. You should find that all the elements balance, 2 sodiums, 2 hydrogens, 2 chlorines. We're still not finished. We need to put in the state symbols, and sodium metal is a solid, hydrochloric acid is aqueous, this is sodium chloride, and we haven't had any other treatment to this salt, so this is still aqueous, and this is a gas. So these are the answers that you should have been getting on your paper. So just give yourself a mark out of, we'll put this as 1 mark for the word equation, 2 marks for the balanced symbol equation with the correct state symbols, and again 2 here. So that's a mark out of 6. So just give yourself a mark out of 6 for this task here. If we have to define an acid, we define an acid as being acidic due to the presence of H plus ions. So I'll repeat again. Acids are acidic, or something is said to be acidic due to the presence of the H plus ions. And the H plus ion is also important because this is how we also test for an acid in terms of its strength. So can we put down that acids, or an acidic solution, let's put this in a better way, a solution is said to be acidic due to the presence of H plus ions. Okay, so when we have H plus ions, we have an acidic solution. Now, what's also important is that in a chemical equation or symbol equation, you may see H plus. So you may see H plus written like this. Now, if you are working with an equation and you're seeing H plus like this and it's an acid and a metal reaction, remember that you need to actually state that the hydrogen in this instance, in the ion state, is aqueous. Remember back to my opening statement about a dilute acid, or the acid releasing the hydrogen in an aqueous state. So if you're asked to write an ionic half equation and you have to include the hydrogen in the ion state, remember that the hydrogen in the ion state of acid and metal reaction is in an aqueous state. So a solution is said to be acidic due to the presence of H plus ions. H plus ions, hydrogen ions, give the acidic nature of acids. The acid, if we're dealing with hydrochloric acid or sulfuric acid, is providing the H plus ions which make that acid acidic. However, when we proceed the reaction forward, now the acid is going to contribute the negative ions in the product. Now you need to listen carefully to what I'm saying here. The acid, which we started as a reactant, as one of the reagents, so the acid used provides negative ions that is present in all the salts, all subsequent salts. So we say the acid used provides the negative ions present in all salts. For example, if you were to have, let's say, sodium chloride, NaCl, or let's say you were to have zinc sulfate. Now, these metals, let's make it another color. So these are the metals. In these compounds, so in NaCl, these metals would be positive. Okay, so these would have the corresponding positive charges here. Now the chlorine would be negative, and the sulfate ion would also be negative. So what you're seeing is that the chlorine has come from hydrochloric acid. The sulfate ion has come from sulfuric acid. Now, the hydrogens that were contributed by the acids earlier have been released as hydrogen gas and have been given off. The remainder of the negative ion has combined with the metal to give you the salt. So this statement, what it is saying is that an aqueous acid, a dilute acid, one provides the hydrogen ions that make it acidic, and those hydrogen ions are released and given off as hydrogen gas as the reaction proceeds. The negative ions will make up the salt in the product by combining with the metal. So the acid used provides the negative ions present in all salts, and I've given you two examples of salts here: NaCl and zinc sulfate. Of acid that you need to be familiar with. So first one is hydrochloric acid. Now, hydrochloric acid, symbol equation HCl. Any salt that is formed when you react a metal with hydrochloric acid will always give you a chloride. Will always give you chlorides. Will always give you chlorides. Now, this is due to the Cl minus ions. Next one is sulfuric acid. And we say symbol equation is H2SO4. And this will always give us sulfates. And this is due to the SO4 2 minus ions. The third acid is nitric acid. This has the formula HNO3, and this gives always nitrates. And it contains the ion NO3 minus ions. So you need to be familiar with these acids because they also turn up in biology as well. Specifically, when we have certain reactions in biology, we will come across some of these acids again. So you need to be familiar and comfortable with the name, the symbol, the chemical formula of the acid, i.e. HCl, H2SO4, HNO3. You need to be comfortable with the corresponding types of salts they may create with metals, chlorides, sulfates, nitrates. And you also need to be comfortable with the chemical formula of their corresponding negative ions within the salts. Now, the reason I've included the negative ions here is because when you come to look at ionic half equations, these will be important, specifically to know when an ion is a spectator ion or not. Okay, I would like you to now complete these questions and post them back to me on the Teams channel. So I would like you to complete these questions, these 3 questions, and post post the answers back to me on the Teams channel. So pause the video here, attempt the questions and post the answers back to me on the Teams channel. Okay, I want you to look at these two exam questions. I want you to pause the video and answer these exam questions on a piece of paper. Alright, so for the first one, we've got lead nitrate solution, and it's made by reacting lead with an acid. They're asking us, what is the name of the acid? So we're given the salt, lead nitrate, and they want us to give them the name of the acid. And the name of the acid is nitric acid. Now, next one. State how solid lead nitrate can be obtained from lead nitrate solution. So, they're asking for a solid starting with a solution. So, going from a solution, how can we get a solid? We evaporate the solution to leave behind the salt crystals. So this is why I said it's important to always be aware of the state symbols when we're dealing with acid and metal reactions. Okay, I want you to look at this question here. We've got some information about acids and alkalis. So just look at that chart, that table there, and I want you to attempt the two corresponding questions. And note, they are only 1 mark questions. Okay. So it says here, draw a ring around the correct answer to complete the sentence. Hydrochloric acid is acidic due to H+ ions. Sodium hydroxide solution is alkaline. Now this is something that I haven't gone on to yet. We'll come on to it when we look at neutralization, but you can just be introduced to it here. An alkaline solution is said to be alkaline due to the presence of OH- ions. Okay, so acidic solutions because of the H+ ions, alkaline solutions because of the OH- ions. Looking at this question, hydrochloric acid is a stronger acid than ethanoic acid. When universal indicator is added to these solutions at the same concentration, the results are different. Describe how the results would show ethanoic acid is a weaker acid than hydrochloric acid. So the opening statement is telling us that hydrochloric acid is a stronger acid. So hydrochloric acid is stronger than ethanoic acid. We are using the indicator, which is universal indicator. And the question is asking us to state how we would show, how the results show ethanoic acid is weaker than hydrochloric acid. We're looking at a color change because the indicator that we're looking at is going to give us various colors corresponding to the strength of the acid or alkali solution. Now, hydrochloric acid, we've been told, is a stronger acid. So we can say that HCl would give a red color, a reddish color, a red color, a dark red or a red color, dark orange you could say, but red would be better because it's at the lower end of the pH spectrum. Ethanoic acid has been told it is a weaker acid. It's weaker in comparison to hydrochloric acid. Therefore, for ethanoic acid, we would say orange or lighter orange or light orange. You could say yellow. You could say it's much yellow, light orange or yellowish in color. You could also start describing in terms of the pH value, numerical value. However, that would be after looking at the color that the indicator gives you and then looking at a chart. For this final question, I want you to take a look at this question, pause the video, and I want you to give the answer back on Teams. So once you get to this question, pause it, pause the video, note down your answers on a piece of on a Word document, and post the answers back to me on Teams.